Good morning, everyone. Here's my second video for Wednesday, integrating e to the x. As you know from the previous video, when you take the derivative of e to the x, that winds up being e to the x. As we discussed in class the other day, if you take the antiderivative of e to the u, that's going to wind up being e to the u plus c. Let's try a few problems. All right, let's take a look at this first one. Now, at first glance, it looks like we're going to have to do some sort of u substitution. Let's try that. Let's have u wind up being 3 to the x. I probably want to think of that as 3x to the negative 1. If I take the derivative of that, that'll wind up being negative 3x to the negative 2, which is the same thing as negative 3 over x squared. That's almost a perfect substitution right there, isn't it? So let's go ahead and take the negative 3. We'll put it out front. E to the u du. Now, okay, Sarah, what are you going to do to change the limits of this problem? That's right, you're going to go ahead and plug in the 2 and the 1. So let's change the limits. So if I put in 2, my limits will be 3 halves. And if I put in 1, that'll be 3. All right, Gus, what's wrong with that? That's right. The limits are backwards. So do the limit property. And switch those limits. So what can we do next? All right, now let's do the antiderivative. So that's going to be 3 times the antiderivative of e to the u, which is e to the u, from 3 to 3 halves. So that will wind up being 3 times e to the third minus e to the 3 halves. And this is our answer. All right, guys, let's try another one. First glance, that looks pretty tough. Let's do a u substitution here. Okay, Austin, what do you think the substitution is going to be? That's right. U is going to be e to the 2x. Now, let's go du dx. That'll wind up being 2e to the 2x. We'll solve for du. That'll be 2e to the 2x dx. That's almost a perfect substitution. Let's multiply by a half. And look what we have here. E to the x is here. E to the x in the problem. Okay, now let's go ahead and do our substitution. That 1/2 is going to be out front, isn't it? Then we'll wind up with the secant of u du. All right, Kelly, what's the antiderivative of the secant of u? That's right, 1/2 the natural log of the secant of u plus the tangent of u, plus c. And let's go ahead and back substitute. That will be the secant of e to the 2x plus tangent e to the 2x plus c. All right, let's try a couple more problems, make sure we have this down. All right, Evan, what do you want to do with this problem first? No, I don't think that's probably right. Let's go ahead and take out a 3 first. And let's go ahead and do a u substitution. How about u being 2x? So du would wind up being 2 dx. Looks like we'll need to do that half trick again. All right, so we have a half with the 3 that's out front, so that's going to be 3 halves e to the u du. All right, Fran, don't you need to change the limits? What do they change to? That's right. How about 2 ln 5? I know what Austin's going to make that. And this one be 0. So wouldn't that turn out to be 3 halves u to 2 ln 5 would be ln of 25? That'd probably be better. E to the u du. So that's going to be 3 halves times the antiderivative of e to the u, which is just e to the u from ln 25 to 0. That'll be 3 halves e to the ln 25 minus e to the 0. So that would wind up being 3 halves. E to the ln 25 is just 25. E to the 0 is 1. So that'd be 3 halves times 24. I believe that would wind up being 36. All right, let's go ahead and do this last problem. This one looks tricky. All right, guys, what do you want to make u be? I bet you guys would guess u to be e to the x plus 1. So du would wind up being e to the x dx. And that's like a perfect substitution right here, isn't it? So let's go ahead and change this. All right. ln 3, when I put that in for u, that would be e to the ln 3, which would be 3 plus 1. This would be 4. And then when I put 0 in, doesn't that wind up being e to the 0 plus 1, which is actually 2? And then this will be 1 over u du. So the antiderivative of 1 over u, isn't that the ln of the absolute value of u from 4 to 2? So that's the ln of 4 minus the ln of 2, which would wind up being the ln of 4 over 2, which is 2. And there's our answer to that one. Okay, our homework tonight is Exponential Functions Day 3, and I should be back tomorrow on Thursday. And you guys spend the rest of the class working on your Math Excel, and I'll see you Thursday. Thanks for listening, everybody.